Hey everyone, so I think we can go ahead and get started here. So thanks everyone for joining the talk today. My name is Tsai. I am a product manager on the Azure Open Source Incubations team. Very happy to be here today. My colleague, Jonathan Smith, if you were looking at the agenda, he was supposed to join us, but he's actually stuck in North Carolina right now. So his family and everything is safe, but all the roads are shut down there by Asheville. So he has had to stay put. So I'm going to cover for him, but send happy thoughts his way as the recovery efforts get underway there. All right. So today I wanted to talk to you about a new project that our group has been working on called Radius. But before we get into it, let's kind of give an overview of the agenda. So I'll begin by giving you an overview of the Radius project. We'll talk a little bit then about the tech sprint that we worked on with the FinOS community and what we were able to deliver as part of tech sprint this year. We'll give a quick demo of the stuff we built during the tech sprint, and then we'll talk a little bit about what's forward-looking for the tech sprint and for the project. So before we jump into Radius, I wanted to give you a brief overview of the group that I'm from at Microsoft Azure. So I'm from the Azure Open Source Incubations team, and we are reporting into the Azure Office of the CTO. Our charter is to work across the company and open source community to solve problems that benefit the industry at large, and not just Microsoft and Azure customers, but the industry all up. Shipping open source code is our top priority, and as a part of that, we partner very closely with the Cloud Native Computing Foundation to provide open governance for these projects. So we donate most of our projects to the CNCF, and we want to build vibrant, innovative communities around each of our projects. So here's just a quick snapshot of our portfolio. If you're familiar with the CNCF, you might know that there are three phases of approval for projects. They start with the sandbox phase, progressed into incubating, and then finally graduated. CADA was one of our first projects coming out of the organization, and CADA is focused on auto-scaling Kubernetes clusters, and it was formally graduated in August 2023. Dapper is another one of our projects that has been in the incubating phase since November 2021, and I believe they are gearing up for graduation soon. Dapper, the project provides integrated APIs that help facilitate communication, state, and workflow in your applications. The next one is this project called Copacetic, or short form COPA. COPA is currently a sandbox project and entered into sandbox in September 2023. Copacetic provides mechanisms to quickly patch container images to greatly reduce the response times required to address security exploits or security vulnerabilities. And then lastly, Radius, which we'll discuss in much more detail later on here. We're very happy to have Radius go into the CNCF as a sandbox project in April of this year. So what is Radius? This slide is sort of a very terse summary, one-line summary of Radius. It's a cloud-native application platform that works on any cloud. So what does that mean? We think about sort of the four pillars of Radius in these ways. The first pillar is centered around team collaboration. So Radius introduces this application and environment model that allows developers to work closely with their operations teams and their DevOps teams to collaborate on delivering an application and deploying the necessary infrastructure for the application. And This is made possible by this feature or this concept that Radius introduces called infrastructure recipes. So you can think about Radius recipes as swappable infrastructure that is based on popular infrastructure as code tools and languages like Terraform and Bicep are the two platforms that we currently support. And these swappable infrastructure recipes are predefined and pre-configured into these environments that are built and configured by the operators, and then developers kind of land in these environments and can leverage these recipes to then deploy their applications very easily. And the best thing about these recipes that the operators will enjoy is that they can then ensure the developers are following IT best practices and IT policy in provisioning their infrastructure. By default, they're compliant with all the policies that they've pre-configured. And then as a part of Radius introducing the application graph or the application definition, you're also able to build like a very rich data set, an application graph, so to speak, of the application architecture that you've defined and deployed. And this data is actually, as you can imagine, quite useful when you want to know how your application comes together. And Radius provides APIs for you to be able to query this data and to be able to get insights and even visualize this data. So later on in the demo, we'll see kind of all this in action, and we can go take a look at what the application graph looks like. And then last but not least, Radius aims to be cloud neutral. We want to enable deployments across on-premises local environments and also on cloud environments, all with one consistent experience. So later on in the demo, we'll show you deploying an application across both Azure and AWS clouds, and then also in a local environment for testing. So to represent things a little bit more visually and the concepts of Radius a little bit more visually, we have a very basic kind of application architecture, like a sample application architecture that I'm showing here. So you have this application that has two containers and backed by data stores that are based on open source technology. So theoretically, this is all very portable, right? You can take this application and probably run it across clouds fairly easily. I say fairly because there's a lot of configuration that a developer will end up having to set up, right? Like each cloud comes with its own set of RBAC rules and networking structures. Each cloud has just slight nuances in how everything gets set up. And then of course, locally, it's a completely different set of rules that you have to work with. So what's supposed to be very easily portable is not so easy for the developer because they now have to learn a lot of like the infrastructure and how clouds operate. And then the operators worry about the developers, whether they're incompliant or they're setting things up correctly, right? So this is where Radius comes in and really shines, right? With Radius, the operators can set up these environments that are pre-configured with all the necessary recipes that their developers can run. So in this example here, you have a local environment that the operator has set up with recipes to deploy local, like Docker-based containers for the data stores that the developer will need to run their application. And then, of course, there's a local Kubernetes cluster to serve as the compute. And then the developer, once they finish testing locally, they can just look at, use the command line rad workspace view to see what other environments are available for them to deploy to. And they'll see that there's an Azure environment pre-configured. So with the same set of Radius tools, the exact same application definition file, they can then leverage the recipes to deploy the same application, but across cloud environments in Azure. And in Azure, the operator knows that they have to pre-configure an Azure cache for Redis. That would be the equivalent of the Redis cache resource. And then Cosmos DB would be the equivalent of MongoDB, and they set everything up with the necessary like RBAC and authentication and networking rules in place for them to deploy onto the Azure Kubernetes cluster. And then same thing with AWS. The operator sets up recipes for AWS Memory DB and Document DB, and then they'll have a EKS cluster ready for them to deploy the same application using the same Radius toolset, but now to an AWS environment. So we'll see all this in action here in a little bit. But before we jump into kind of the demo, I wanted to walk through a little bit about what we did for the FinOS tech sprint this year. So when we looked at the TraderX application, so TraderX is a sample application created by the FinOS community that is supposed to represent a reference architecture of a distributed trading application that you can deploy locally and test and experiment with. We saw opportunity to take this application, add Radius to it so that the deployment for local and across clouds becomes very easy. So as a part of the tech sprint, we first then built an automated CI pipeline using GitHub Actions. This automatically builds, scans, and publishes the container images for this application and publishes them to the FinOS container registry that then we can go pull and leverage to deploy with Radius. And then as a part of the tech sprint, we created a Radius application definition, and then that allowed us to manage and deploy TraderX using the Radius toolset. So here's the demo, the exciting part of the presentation. So what I have here is just a code space that I have set up for this demo. And it's a GitHub code space, and it's basically my local environment. My local machine is this code space machine. And in this machine, I've gone ahead and cloned the TraderX repo. So you'll see the TraderX landing page here. This is kind of describing what TraderX is. It's, as I mentioned before, a sample application created by the FinOS community. And the deployment experience for TraderX today is actually quite good if you're developing locally on your Docker containers. So I'll pop open their Docker Compose, and you'll see in here the Docker Compose file has a couple of things that are set up, but largely set up for local development, right? Like the networks and things and various other configurations are hard-coded in here. And when you're looking to deploy this into the cloud, it may not be quite as simple, right? Because you have to then set up a bunch of things on your Kubernetes cluster in the cloud, and then also set up all the networking and infrastructure associated with it. So the challenge for us for the tech sprint was to then take this and ratify it, so to speak, and use Radius to deploy this application. So I mentioned before that in order for us to do this, we had to first build and publish these application images into a registry, because the current experience is the Docker Compose actually builds the image from scratch each time, but we need the images readily built. So we added a workflow, and this is just a GitHub Actions workflow that builds and publishes the application images to the GitHub container registry. And it builds each individual container driving the application and puts it into the container registry, and it also adds a scanning step to scan for any potential vulnerabilities before publishing. So we have that set up, and it runs with each push to the main branch of the TraderX repo, and then the images are made available in the GitHub container registry for FinOS. So we'll take a look at the Radius artifacts that we created as a part of this exercise. So we go into there's a Radius folder, and in it you'll see this app.bicep. So this here is the application definition for the Radius, for Radius, and the application definition for this TraderX application. So you'll notice it's a app.bicep file. So for those of you not familiar with Bicep, Bicep is very similar to Terraform. It's an infrastructure as code language and platform that you can use to define and deploy infrastructure. And we chose Bicep to be the sort of base language for the Radius application definitions because it's got some very desirable features like strong typing and integration with IDEs to provide error correction and autocomplete and things like that. So you define, the way it works is you define your applications using Bicep, but all the recipes that your operators define and register for you in your environment, those can be in either Bicep or Terraform. So the idea is to meet developers and operators where they are. So you can actually, if you're integrating Radius into an existing application, you can just bring in all your existing Terraform modules, package them as recipes, put them in the environments, and then your developers can have access to those recipes when it comes to deploy time. So I'll walk through a couple of the elements here of the application definition file. So you'll see here every time a resource type is declared, it means that Radius will take, it's a signal for Radius to create and deploy and provision a particular resource that could make up a component of your application. So in this case, we have a container resource called database, and it pulls the image from the FinOS container registry, and this image drives this particular container. And then if you scroll down here, you'll see additional elements to the application definition. For example, here you have environment variables. So just like in the Docker Compose file where you can configure environment variables, you can configure them here in the Radius application definition, and Radius will inject these environment variables into your container at deploy time. And then this here is probably the most exciting feature, I think, in the Radius application definition. And this is a feature unique to Radius called connections. And when we sought out to build this feature, we wanted it to be very magical and very, very intuitive for the developer. Like the developer can declare their intent to connect two services together, and when Radius runs in the deployment, Radius will do a lot of the legwork to actually make the connections happen. So Radius will follow some conventions to inject the correct environment variables, for example. Radius will go into the recipes to grab all the necessary credentials and all the network policies and set things up behind the scenes for you so that when you deploy, the connections are set up and the services are connected to each other. And then you might remember I talked about the application graph. So these connections here that you define in the application definition form the edges between the nodes of your application graph. So you can imagine that by writing your application definition and using this application definition to deploy, you're building some rich kind of graph data structure about your application architecture that Radius actually stores, and you can query and look at for insights and visualization. We'll show a little bit of that in the demo once we deploy it. So with that in place, the application definition file is in place. We have each container, each service defined. We can go ahead and do the deployment. So I'll pull up the console here, and you'll see that I'm pointed to the radius-traderx directory. And this is the directory that houses our app.bicep file. So you'll see here app.bicep. This is the application definition. So the entry point for Radius is a command called rad init. So when I run rad init, it will install Radius into the Kubernetes cluster that I'm currently pointed to. So in this case, it installed Radius version 0.38 into my local K3D cluster. And then it does a couple of things to get you to get quickly started with Radius in your local environment. It creates a default environment for you and updates some local configuration so that you can then start working in your local environment with Radius. So now that we have that set up, we can do a rad run and then app.bicep. So rad run directly in the Radius-TraderX folder will take the app definition that I just showed you. Radius will take that app definition, build the application, and then deploy it. And this is right now pointed to my local cluster, so I'm deploying locally. I'm a developer I'm in the phase of the application development process where I'm ready to see how everything integrates and ready to see how the local integration tests work. And you'll see the deployment progress here. Most of the containers have been deployed. Ingress is the final one, I believe. And when it completes, we can interact with the application. So it's completed. And what rad run also does is that it runs the application and also port forwards automatically all the ports that are exposed in your application so that you can interact with your application once it gets deployed. And you'll see once it gets deployed and starts running, you'll see all the application logs show up in the terminal. We can take a look at the ports that were forwarded and available for us to look at. And I know from the TraderX documentation that the TraderX application UI is on port 8080. So we'll open up that port, and then we can interact with the application, the TraderX application. So everything seems to be running fine. The UI runs fine. And then you can actually look at all the data that's been pre-populated already into the application. Right, so right now the application is running locally on my Kubernetes cluster on the local machine. And we'll show you how we can deploy this to the cloud in a little bit as well. But before I do that, I wanted to go back to the forwarded ports and point our attention to this port 7007. So this is an additional port that rad run port forwards. And what this is the Radius dashboard. So it's an instance of the Radius dashboard that's installed along with your Radius instance in the cluster. And the dashboard is meant to be a developer dashboard that a developer can visit after their deployment to view kind of their applications and view what's been deployed. And the dashboard is built on top of another CNCF open source project called Backstage. Some of you might be familiar with it. It's a developer portal development platform. So it's basically a Radius skinned kind of instance of Backstage. And the cool thing about Backstage is it works on a kind of a plug-in architecture. So in the future, we can actually expand the Radius plugin into the Backstage ecosystem, so we can work well with other instances of Backstage or your own instances of Backstage. And of course, we chose Backstage because it's a very mature, popular technology, and two, it accelerated our UI development a ton. And here's the dashboard, and I'll just run through a couple of things in the dashboard that I wanted to highlight. You'll see environments. It will show you all the environments that are available for you in your particular cluster. And in this case, I only created a default environment for testing. And then it shows you all the applications that have been deployed. So we actually just deployed the TraderX application. So we can click into resources. And when you click here, this actively calls the Radius APIs in your cluster to fetch the application graph data or the application details. So once this loads, it will show you in text all the resources that you have just deployed as a part of your application. It's taking a little bit of time, but this is all because it's querying the application graph in real time in the cluster. All right, while it's thinking, I'm going to go over to the application graph and take a look at that instead. So here's the application graph. So remember I showed you the connections feature? Well, this is the application graph visualized. So you'll see here that you'll see all the connections that were defined as and represented as edges between the nodes, which are the actual containers and the services that were deployed. And I want to pull up the TraderX documentation in the repo. This is a static architecture diagram, a C4 architecture diagram of the TraderX application. So this here represents the architecture, but it's static, so it's obviously just a representative of like what the architecture should look like. The Radius application graph shows you what exactly you deployed. So this is a live look at the application graph or the architecture as deployed. And of course, this gets re-rendered every time you refresh the deployment. So it's always up to date, and the application becomes this sort of self-describing entity. So we'll go back here to our terminal, and I will stop the application and show you one more thing. We can do a rad workspace list. And what this shows you is all the environments that have been pre-configured for me by my operators. So I can see here that I've been sort of partying in the local default environment so far, but I realized, oh, I actually have these prod-like AWS and Azure environments available for me to deploy into. So as a developer, and this is a true story, I'm acting as a developer here. Somebody on our team provisioned all these environments for me, and when I sought to do this project, I saw that we had these environments, and I was like, hey, I bet I could deploy to these environments now without having to know exactly how they're configured. And that turns out to be the case, so I'll show you that now. So I've opened two windows here. We'll cd into the Radius directory, and over here we'll do a rad deploy, and then the same application definition file. So note that it's the exact same application definition file we were using in local, but this time I'll just point this to prod AWS. So we'll run that, and then we'll do the same thing here, rad cd into the Radius folder, rad deploy, and then this time we'll do Azure on this window. So what it's doing now is actually deploying my containers into EKS and AKS respectively. And once it completes, I'll show you kind of all the resources that were deployed as a result of this deployment. So keep in mind that I took the TraderX application as is, so they're all just generic containers. They're not leveraging databases quite yet. That's sort of the next step that we'll describe later. But we're deploying these sort of generic application containers across both clouds right now. So you'll see here, it's a little small, but deployment's complete on both. And then we can now do a rad app graph. And then I'll do the prod AWS workspace. And then same thing here, rad app graph, prod Azure workspace. So what this is doing now is it's querying the Radius instance in each of the EKS and AKS clusters to gather the data of the application graph for the application that had been launched or had been deployed. So you'll see here a textual representation of all the connections between all the particular containers that we defined. And then you'll see all the resources, all the Kubernetes specific resources that Radius provisioned and deployed on your behalf as a part of the application deployment. So it's got the Kubernetes deployment, Kubernetes service, some RBAC artifacts, and all these were done by Radius. You didn't have to go in and manually create the CRDs and whatnot in Kubernetes. Same thing on the AWS side. All the resources are deployed according to what was set up for your environment. So with that, we have, that sort of concludes the demo, and we have everything deployed successfully in the local and the cloud environments. I'll go back to the slides and kind of talk a little bit about what's remaining for us beyond what we accomplished in the scope of our tech sprint. So we want to ratify the remaining components of TraderX. We want to make the database and the message bus resources configurable. So basically replace those generic, like custom-built database and message bus containers, and ratify those so that you can then switch those out for SaaS type of databases at deployment time, right? So you can imagine if we changed it to Postgres, we can then switch out between RDS, AWS RDS for Postgres, or Azure database for Postgres. And then same thing with the message bus resources. And then we want to build an automated CD pipeline via GitOps. So Radius is currently building integration with Flux and Argo CD for you to be able to do continuous deployment with your GitOps platform. So once that feature is available, we want to bring that into TraderX and kind of implement a CD pipeline with GitOps using Radius as well. And then finally, we want to package this all up into a nice multi-environment deployment kind of reference architecture so that we can help users of TraderX set up this similar one-click deployment experience of TraderX to any cloud. And then, of course, interact with the application graph and build additional enhancements to that application graph. If you'll notice, the application graph I showed you, it's in its very nascent stages. Right now, we're just using the standard visualization tools that Backstage provides. So there's a lot of opportunity to clean that up and make it a little bit more presentable, and also to make the Backstage plugins portable so that folks can bring in Radius into their own Backstage instances. Yep, so that's my presentation. Thank you for listening, and I have some QR codes up here. These are to the Radius website, the Radius overview website, and then also to the Radius GitHub. Encourage you to go visit these places to learn more, and of course, we are an open source project, so open up the GitHub, and if you're interested, you can play around with it and go contribute to it as well. Thanks.